Hello, my name is Waleed Krifa, and this is my prop for Bio E128. So, the subject of my prop here of my research is that fruits can defend themselves against predators such as invasive species, both fungi and insects. For what I found, however, I focus a lot more on fungi in the articles that I cite here, but it is applicable to both. So let's get started. So this is the figure that I made through the researching the articles. I basically found that there were tests done both with amide extracts, which is one of the types of chemicals that allow for fruits to defend themselves, and the size of fungi that were already present in the fruit. So amides basically are a secondary metabolite that are meant to defend fruits from invasive species. There's also phenolic compounds, which I will be going into in a little bit as well. And basically, in this test here, the amides were injected into specifically piper fruits and are being compared in various dosages with respect to the size of the fungal infections that were already present on the fruits. And what was found here is that there is a direct relationship between the amide extracts that were injected and the size of the fungi. So basically, the more amide extract that was injected, the more the size decreases on the fungi, which shows that it can be used as a deterrent for invasive species like fungi. And so now, why is this important? Well, amides and phenolic compounds are the primary chemical source for fruits to defend themselves against these invasive species. When tested specifically against fungi, especially those specifically designed to invade fruits in the wild, both of these compounds have proven to be a solution to preserve the health in fruits, and it's basically a good deterrent and treatment for the fungi. As fruits are, so basically the whole importance of this all is that fruits are a consumable for us humans, and it is important that we find a way to enable these fruit defense to basically replicate what is seen in the wild so that we can preserve the health of these fruits and be able to provide it to people to eat. So here's from the first paper that I found with Whitehead and colleagues. This is basically showcasing the various different amides that are found in fruits, both specifically piper fruits, in unripe and ripe piper fruits. And I basically wanted to showcase this as a comparison as to like if a fruit is ripe or not, to show like how much of the chemical compound is present. It is pretty consistent. There's not too much of a difference between most of them. However, on average, unripe piper fruits did show to have more of a concentration of amides. Uh, for my second figure here, I basically got this from Mason colleagues, the article here, and this basically showcases how much fruits have their phenolic compound content compared to plants, which would naturally be having a lot more as they are targeted a lot more by the invasive species. However, I just wanted to showcase this to show, so to see that fruits have a comparable amount of phenolic content to flowers and leaves, which indicates again that they are abundant with these chemical compounds, and the reason why is to deter these invasive species and enable fruit defense, which is a great example of chemical ecology at work, since they are using these compounds to their benefit in the wild. And that concludes my presentation. Thank you.